Hello everyone. This video is about engineering system. The word system is very common to use in engineering analysis. We use that word when we do thermodynamics analysis, when we do heat transfer and mass transfer analysis. So what's actually system is? What is a system? Let's assume that we are having that black uh, uh, area here and we have randomly distributed dots on that page here. Then I ask you to count the number of dots or dashes in a specific zone. Let's assume this is the zone I'm interested in. So if that's going to be your focus area of study or analysis, this is what we call it system. So the word system is simply stand for the focus area of analysis. So now you need to count the number of dots, and that's the analysis that you are performing for that system. System is usually defined by what we call it the boundaries, right? So everything inside that boundary is called system, and everything outside the boundaries we call the surroundings. Remember, that boundary is kind of a line of illustration, could be physically not exist. So sometimes we draw a dashed line here. So it could be a real line or could be actually an imaginary line that presenting the separation or the separating lines between the area of focus to analyze and the outside area, which is the surrounding. So that's the definition of the system. And the system, as I mentioned, is completely defined by the boundaries and the surroundings as well. So the second question is, what are the different types of systems? The first and very common one defined in engineering analysis is actually called the control mass system. So if I draw my system here, that's my boundaries. Surrounding is outside. I'm interested in this, what's inside that line. And this is my system, and my system has a mass. So the mass inside that system is actually constant. How to have that constant mass system, which means that the boundaries of that system does not allow for mass in or mass out through the boundary of that system. So the control mass system is a system that does not allow for mass to penetrate or go through the system boundaries. So that's how we keep the mass inside that system actually constant. But the control mass system has some exceptional because it actually cannot restrict the transport of energy. So there would be energy can cross the boundaries of that system. So it is allowed. So in a simple word, control mass system is a system that no mass can transfer across its boundary, but energy can cross its boundaries. When I say that energy could be in the form of heat or a form of work and so on. So different forms of energy can penetrate or can go through the boundaries of that system. So again, the characteristics of the control mass system is the mass inside the system remain constant. No mass is allowed to cross the boundary. So there is no mass in or mass out. And these two will lead to keep the mass of the system always constant. But there is no restriction on the heat or work, which different forms of energy to cross the boundaries of that system. So that's the first type of system that we analyze. A very common example of that system, especially in engineering application, is a tank we call that actually rigid tank. And the most famous example as well is, I need to do some better engineering drawing here. So let me open this. It's actually what we call the piston cylinder system, which we use a lot to present different types of systems, especially when we do uh, internal combustion engine analysis and stuff like that. So these are the two common examples when we deal with control mass system. Now, the mass inside the tank will never change. There is no way for a mass to leak out or mass to leak in. Also, the mass, uh, uh, this gap is here just for clearance because it doesn't make sense if they have the same dimension, but this is how we standard draw the piston cylinder system. So the mass inside these two examples here is not going to change. The second types of engineering system that we use a lot is actually called the control volume system. Let me write down that. Control, that's system number 2, is control volume system. So if I draw that irregular shape here, that's my system here. In the control volume system, the system initially has mass inside, but this types of systems is actually allowing for mass to leave in and out through its boundaries. So mass is allowed to in and out. So maybe mass in or mass out. And this could happen at different location. In/out. Mass in/out. In this case, I cannot say that the mass inside the system is going to remain constant, right? It's going to remain constant in a special case. So the system mass, so in this case, there is mass in/out through system boundaries. In this case, if the summation of all the mass in equal the summation of the mass out, all the masses going out of the system, in this case, I can say that the mass inside the system will remain constant. You can imagine if you have a tank with multiple openings and there is mass in and out, but the summation of all the masses going in and equal the summation of the masses going out, the mass inside that tank will remain the same. And this is what we call actually the steady state situation. But if the summation of the mass in does not equal summation of all the masses going out of the system, and in this case, I cannot say that the mass inside the system, it will never becomes constant. And this is what we call it the transient or unsteady situation. So the mass of the control volume system is depend on if you are applying steady or unsteady conditions here. But the second important characteristics of that control volume system is actually it's also allow for energy to get in and out. So it's very similar to the control mass system. So there is energy in or out. So energy is allowed to go in or out. That's the second important characteristics of the control volume. The third system, which is a very special case of either the control mass system or the control volume system, is when you actually isolate that system or insulate that system from exchange energy. So the energy is no longer allowed either in the control mass system or the control volume system. So in the control mass system, mass is not allowed to change. Remains constant, but energy was allowed. But if I stop energy to transfer through the boundaries of that system, this means that your systems is no longer called control mass. We call that actually adiabatic system. So adiabatic system could be a control mass system or a control volume system when the energy is no longer allowed to cross the boundaries of that system, in addition to the other characteristics related to the mass itself. I hope that's clearly explained what's the definition of engineering system and what are the different types of engineering system that we use in analysis. A control mass system, whereas the system has a fixed mass inside, energy is allowed to go through the boundaries. Control volume system, mass inside the system is conditioned by the steady or unsteady condition, which means that maybe the mass will be constant or not, but energy is still allowed to go. And the special case out of these two systems is it's called the adiabatic system or insulated system or isolated system, where we actually restrict energy as well to go through the boundary of either the control mass system or control volume system. I hope that's explained well, the definition of a system and different types of system. I appreciate if you like, share, and subscribe to the channel so you can receive a notification when a new video get released. Thanks for your time. I will see you in a coming video.